Welcome to the lecture video for Pre-Calculus, Section 5.1 on Composite Functions. This lecture will be broken into two parts, so this is Part 1. Function composition is a new operation where the operator is this little circle here, so it sort of looks like a degree symbol. It's slightly bigger, and this is called composition. So we've got this formula here that says g of f of x is equal to, another way of writing it, g of f of x. So the way that we say it is g of f of x. So we start with two functions, f and g. The composition of g with f is defined by this formula. So what this means is x is an element of the domain of f of x, and then f of x is an element of the domain of g. So we'll learn how to create these functions g of f of x from two existing functions, f and g. And the way that we say this is g of f of x, g of f of x, g of f of x. So looking at this first example that says find g of f of 1, whenever you've got a numerical input, my input into the function f is 1, I'm going to get a number as a result. So my answer is going to be a number. So let me just point something out that may be confusing. In the past several units, we dealt with negatives under the radicals in the context of solving for complex roots of x squared and x cubed and x to the fourth polynomials. Okay, so when we're dealing with function composition here, we're strictly dealing with numbers that we're plotting or think of as being able to plot on the xy plane. So we're talking about real numbers right here. So that's why we have to restrict square roots to only having positive numbers underneath the radical. So we're dealing with real numbers for this composition section here. So we're given three functions here, f of x, g of x, and h of x. And in the series of examples that follow, we're going to use those three functions to do some composition. So this first example says here, compose g with f. All right, so what we're asking for here is, what is g of f of x, where x is 1, so we're trying to find g of f of 1. Okay, so we want to know what that is. So that means first we have to find f of 1, and once we find f of 1, we plug that into the g function, and then that should give us a numerical answer. All right, so f of 1 is equal to 1 squared minus 4 times 1, which is equal to 1 minus 4, which is negative 3. All right, now I take that value and I plug negative 3 into the g function, and I'll get 2 minus the square root of negative 3 plus 3, which is equal 2 minus the square root of 0, which is equal to 2. Okay, example 2 says find f of g of 1. So the f and the g are in reversed positions on example 2. So this time we're going g into f. So we're trying to find here, this is the same thing as saying find f of g of 1. So we're going to find g of 1, and then we're going to take that number and we're going to plug that into the f function, and then we're getting a real number as a result. Okay, so g of 1 is equal to 2 minus the square root of 1 plus 3, which is equal to 2 minus the square root of 4, which is equal to 2 minus the principal square root of 4. Principal square root of 4 is 2, So that's 0. All right, so understand on these examples that we're taking the principal square root. Instead of getting 2 numbers out of this result, we're only going to get 1. All right, so then we're going to take 0 and we're going to plug that into the f function. So we'll get 0 squared minus 4 times 0, which is equal to 0 minus 0, which is equal to 0. So our numerical result is f of g of 1 is equal to 0. In this example, we're asked to find g of 6. So we have to use the g function twice. So the first thing we're going to do is find g of 6 and get that number, and then we're going to plug that number into the g function again, and then we'll get out our numerical result. So the first thing we do is we find g of 6. So that's 2 minus the square root of 6 plus 3, 2 minus the square root of 9, 2 minus the principal square root of 9, which is 3. So this is negative 1. So we put negative 1 into the g function again, and we're going to get 2 minus the square root of negative 1 plus 3, which is 2 minus the square root of 2, and that's a real number, so we can leave it like that. So that's approximately equal to 2 minus roughly 1.4. So that's roughly 0.6 something or other, but this is the more the best way to leave it. That's an exact number, whereas this right here is a decimal approximation, and you'd have to keep more digits than that in order for our online homework reader to accept it. In other words, rounding to the 10th place is rarely an acceptable answer in our homework system that we're using right now, but this should always be, unless there's some kind of a glitch that we uncover, an acceptable answer to these kinds of problems. Okay, I'm going to skip to example 9 now because I'm breaking this lecture up into 2 sections. Part 2 is going to be the section that requires the writing, more writing of stuff, more algebra. Okay, so example 9 here says big F of x is equal to the absolute value of 3x minus 1. Find 2 functions, f of x and g of x, so that big F of x is equal to the composition of f and g, meaning the g is going into the f, and it's going to make a function that looks like this. So the way that we do this is we kind of think about the form of this big F thing here. So the way I look at this is I've got this absolute value thing, which is going to accept some kind of input which looks like this. So it makes sense to think of 3x minus 1 as going into the absolute value function. Okay, and since these things we think about as the inside going into the outer function, then it makes sense that the g of x is going to be the inside stuff, 3x minus 1, which is then going to go into the f of x, which is the outside thing. So this. Now let's see if that makes sense. If I want to find f of g of x, that means I'm going to plug the function g of x into the function f of x. All right, so this is f of x. Let's leave some room. And g of x is got to go inside there where we've got that x. So I'm going to put g of x inside where we would have that x in the f of x function, and then we've got it. We've created big F of x, which is equal to the composition of f of g of x. So we've determined that g of x must be 3x minus 1, the inside part, and f of x must be the absolute value of x, the outside part. And then this replaces x to get big F of x. Okay, here's another one like that. So we've got this function big H of x is equal to the quantity 2x plus 3 all cubed. So we're looking for an f of x and a g of x such that h of x is the composition f of g of x. So that means g of x is going to be the inside. So here, this would be your inside. And f of x would be your outside. So your outside is going to be cubing whatever you've got inside. So that's x cubed. So if I write that, g of x as my inside function is going to be 2x plus 3, and f of x as my outside function is going to be x cubed. Okay? So that will allow me, if I look at this, let's look at this, h of x is equal to f of g of x, where g goes into f. And that makes sense because g going into f would mean 2x plus 3 has got to go into where you've got x cubed. So x cubed, right here, I'm going to put 2x plus 3. All right, so that would look like 2x plus 3 instead of x cubed, which is what we've got up here. So our answer is g of x must be 2x plus 3, and f of x must be x cubed. So let's do one more like this. Big B of x is equal to 7 divided by x squared minus 1. So we're looking for an f of x and a g of x so that big B of x is the composition f of g of x. So g of x is the inside and f of x is the outside. So let's look at the outside function first. So we've got that 7 on top here, and then we've got something here where it looks like we got to replace this x squared minus 1 as your x spot right there. So we can think of our outside function as being f of x is equal to 7 over some place x there where we're going to then put in x squared minus 1 so that it looks like this here. So that means our inside function g of x would have to be that x squared minus 1, which we're going to put right here in this spot here. So if I write that out, I can say b of x, which is f of g of x, is going to equal, so let's see, f is 7 over x. This is where our input is going to be g of x. So that's going to equal 7 over, sticking g of x in there, x squared minus 1. So that works with g of x is equal to x squared minus 1, and f of x is equal to 7 over x. So our answer would be a g of x, x squared minus 1, and an f of x, 7 over x, will give you this composition here such that it looks like big B of x. So the last thing we're going to do on part 1 is look at some graphs. So it says use the graphs to find the function value indicated here. So we're composing various ways g and f together. So this is the graph of f of x. This is the graph of g of x. We're going to use these two graphs to pick off values. All right, let's just do the first one here, g of f of 1. So g of f of 1 is equal to g of f of 1. So we're going to find the f of 1 value, and we're going to plug it into the g function. All right, so to do that graphically, first we're going to find f of 1. So we're going to look at the f graph here. So when x is 1, f of 1 is 2. So that means f of 1 has the value of 2. So then we're going to take f of 1 and we're going to plug it into the g function. So that means we're going to find g of 2. We're going to find that from the g graph. So here's the g graph. So when x is 2, then g of 2 is 3. So our answer is 3. So the next one says, find f of g of 2. So that's the same thing as saying, what is f of g of 2? So that means we need g of 2, the number, to put into the f function. So we look at the g graph first, and the input is x is equal to 2. So g of 2 is 3. G of 2 is 3. Now we take g of 2 and we put it into the f function. So f of g of 2 is f of 3. So now I'm on the f graph at an input value of 3. So I get 3 as f of 3. So my answer is going to be 3. And the last one says, what is f of 1? So we're going to use the f graph 2 times this time. So f of 1 is equal to f of the value f of 1. So we need f of 1. So 1 is the input value, the x value, on the f graph. Here's 1. F of 1 is 2. All right, and now we need to find f of 2, and that should give us our answer. So we've got to use the f graph again. This time, the input value, x is 2, f of 2 is 3. So the answer is 3. So this is the end of part 1 of the lecture, and now you will need to listen to part 2 of the lecture, taking notes the whole time, right? And then you'll be ready to do the problem set.